Hey everyone, in this video, we are going to put everything together. Instead of just reading the box plot, we are going to create one ourselves. We'll also learn how to identify outliers. Let's start with example 3. We're given this data set. The first thing we always check is whether the data is already sorted. Fortunately, this is already in ascending order. That makes our work easier. Question A, find the 5-number summary. I am going to use the TI-84 calculator to find these 5 numbers. Hey, I'm going to show you how to find the 5-number summary using a TI-84 calculator. First, enter your data. Press Stat, choose Edit, and press Enter. Select any list on the screen and enter your data. I'll use L1. 18, enter. 20, enter. 23, enter. 27, enter. 30, enter. 33, enter. 36, enter. 36, enter. And 60, enter. After entering the data, if you want to leave the screen, press Second Mode. Next, press Stat. Use the right arrow key to move to Calc. Then select the first one var stats, and press Enter. For the list field, enter the list where you store your data. Since I use L1, I enter L1 by pressing second 1. Leave this field blank because there are no frequencies. Highlight Calculate and press Enter. The calculator will display several statistics. Use the down arrow to scroll through the results until you see minimum, Q1, median, Q3, and maximum. These 5 values make up the 5-number summary. This is our 5-number summary. The minimum value is 18. Q1 is 21.5. Median is 30. Q3 is 36. And maximum is 60. Part B. We want to construct the box plot. A box plot is built from the 5-number summary. Now we already have the 5-number summary, so we can start building the box plot. The first thing we need to do is create a number line. We want the number line to include values from at least 18 up to 60. This is my number line, and this number line starts at 16 and ends at 62. So that it includes the minimum 18 and the maximum 60. Next, mark the 5-number summary values. The minimum is 18. Q1 is 21.5. Q2 is 30. Q3 is 36. And maximum is 60. Now, let's draw the box. The box always starts at Q1 and ends at Q3. So the box begins at 21.5 and ends at 36. Next, Draw the vertical line inside the box at the median. The median is 30, so I draw the vertical line here. Now, draw the whiskers. The left whisker extends from Q1 down to the minimum value, 18. The right whisker extends from Q3 up to the maximum value, 60. And this is our box plot. Take a moment to look at the shape. Notice that the right whisker is much longer than the left whisker. That suggests the data is stretched further on the right. In other words, some larger values are pulling the distribution in that direction. This observation will become more important when we talk about outliers. Now, let's determine whether the data contains any outliers. To do this, we'll use the IQR rule. Step 1, find the IQR. IQR equals Q3 minus Q1. Q3 is 36 and Q1 is 21.5. And 36 minus 21.5 is 14.5. Step 2, find the lower fence. Lower fence equals Q1 minus 1.5 times IQR. Q1 is 21.5 and IQR is 14.5. 21.5 minus 1.5 times 14.5 is negative 0.25. Step 3, find the upper fence. Upper fence equals Q3 plus 1.5 times IQR. Q3 is 36 and IQR is 14.5. And 36 plus 1.5 times 14.5 is 57.75. Now, we compare the data values to the fences. Any value below negative 0.25 would be an outlier. And any value above 57.75 would be an outlier. There's no data value that is less than negative 0.25. 60 is greater than 57.75, therefore 60 is an outlier. Now here is something important. When an outlier exists, many box plots are drawn as modifying box plots. Instead of extending the whisker to the outlier is plotted separately as a point. So in a modifying box plot, 60 would appear as an individual dot. Now, let me show you how to create a modifying box plot. We'll use the same number line in question B. The box does not change. Q1 is at 21.5 and Q3 is at 36. The median is at 30. The box remains exactly the same. The left whisker stays the same because there are no low outliers. The left whisker extends from Q1 to the minimum value of 18. Now, let's focus on the right side. Earlier, our right whisker extended all the way to 60. But since 60 is an outlier, we remove it from the whisker. Instead, the whisker should stop at the largest value that is not an outlier. Let's look at our data again. 60 is an outlier. After removing the outlier, the largest remaining value is 36. So the right whisker stops at 36. Notice that the whisker has no length because Q3 is 36. That's okay, it can happen. Now place a solid dot at 60. That dot represents the outlier. This is our modified box plot. Notice the difference between the regular box plot and the modified box plot. In a regular box plot, 60 was treated as the maximum value and included in the whisker. In the modified box plot, 60 is displayed separately because it is unusually far from the rest of the data. This makes it much easier to identify unusual observations. Whenever you see a separate point beyond the whisker on a modified box plot, that point represents an outlier. For this dataset, the value 60 is the only outlier.